Okay, this is on page 64. So on page 64, we're supposed to find the solutions to x squared plus 5x minus 3 by using the quadratic formula. Okay, so the good thing is they reminded us what our equation has to look like. It has to be set equal to 0, and it is. And then they even gave us the quadratic formula. So let's go ahead and label my a is the number in front of my x squared, so my a is 1. My b is the number in front of my x, so it's 5. And c is negative 3. So we're going to take these three things, plug it into the quadratic formula. So x is equal to negative b, negative 5, plus or minus the square root of b squared minus 4 times a times c, all over 2a. So now we're going to simplify. X equals negative 5 plus or minus 5 squared is 25. Negative 4 times 1 times negative 3, that's going to be a positive 12, all over 2. So x equals negative 5 plus or minus 25 plus 12 is 37, all over 2. So 37 won't break down at all. So I have negative 5 plus the square root of 37 and negative 5 minus the square root of 37. So my answer has to be either B or D, and it's B because my 5 is negative. Okay. The next one, what is the y-intercept of 3x squared minus 2x plus 1? There's two ways we can solve this. Okay, first, good math teacher way. When I'm finding the y-intercept, I'm going to let x equal 0. So when I plug 0 into this, 3 times 0 squared minus 2 times 0 plus 1, so I get 1. So when x is 0, my y value is 1, b. Now, if I didn't remember how to find the y-intercept by letting x equal 0, we can graph it. Okay, so in my y equals, I would put 3x squared minus 2x plus 1. Okay, I'm going to graph that in my standard viewing window. And I want to know where it crosses the y-axis. Well, when it crosses the y-axis, x is 0. And it looks like it crosses at 1, which we know that's our answer. But I also could hit trace, type in 0, enter, and my y-intercept is 1. Okay, so let's look at the next one. In what direction does the graph of this parabola open? Well, of course, we could graph it, but we should know that if there's a negative in front of the x squared, that's going to make my parabola open down. So my answer is D. If we forgot what it looks like, we put that in our calculator. Y equals negative x squared. Graph that, and it opens down. Now, this would be different if that were in parentheses. If it were this, negative x times negative x is x squared, and it would open up. Okay, but since the negative is not being squared, that's going to open down. So my answer is D. Okay, what is the y-intercept of the graph of this equation? Again, to find the y-intercept, let x equal 0. So I'm going to plug x as 0 in for my x. So y equals negative 4 times 0 squared plus 2 times 0 minus 3. So I have 0 plus 0 minus 3. So my y-intercept is negative 3. If I didn't know or remember how to do that, I'd put that in my y equals negative 4x squared plus 2x minus 3. Graph it and see where it crosses the y-axis. And it crosses the y-axis. It looks like it's negative 3. I can hit trace. When x is 0, y is negative 3. What are the coordinates at the minimum point of x squared minus 4x plus 3? Okay, so I need to find the vertex of this. We found the vertex before by negative b over 2a. So I could do it that way. B is negative 4, a is 1, so I have 4 over 2. So my vertex is when x is 2. Okay, let's graph it. I'm going to graph this. I'm going to put in the equation x squared minus 4x plus 3. Graph. And the question is, what is the minimum? Okay, well, we know our minimum is right here. Our calculator will find the minimum for us. So we go second, trace, number 3 for minimum. It's going to ask us to go to the left of the minimum. So we can move our cursor to the left and press enter, or I can type in a number. Right bound, that means go to the right of your minimum and press enter. Guess, I'm going to put my cursor where I think the minimum is and hit enter. My minimum, do you see they just haven't rounded this to 2, is at 2, negative 1. So my ordered pair is at 2, negative 1. Now, so we got my x value is 2. To find my y value, I would plug that in, and I get 4 minus 8 plus 3, negative 4 plus 3, negative 1. So 2, negative 1. Okay. Which function represents this graph? So let me get it a little smaller so we can see the entire thing. Okay. So which function represents this graph? Well, first of all, we know that this graph opens down, so my x squared term has to be negative. So I can automatically count out b and I can count out d. Okay, so we need to figure out, is this negative 1/4 x squared minus 2 or negative 4x squared minus 2? Well, I can graph that and see. Now, when we graph it, see their window? Their window isn't from negative 10 to 10. It starts at negative 6 and goes to 6 on the x and y axis. So we may want to change our window so that it matches up better. So I'm going to put this in our y equals first. I'm going to put in a. So a is negative 1/4. And I'm going to put that negative 1/4 in parentheses. And then my x squared minus 2. Okay, I'm going to change my window, and I'm going to go from negative 6 to 6 on my x and my y axis. Okay, and then I'm going to graph. Okay, there's that graph. Now, I'm going to compare that graph A to graph C. That was my other choice. So I'm just going to graph these at the same time. I'm going to put graph C in my Y2. I need to go over here and get rid of this before I do that because I was graphing inequalities before. All right, so I'm going to graph negative 4 x squared minus 2. And I'm going to look at the difference. There's my first one. There's my C. So obviously, graph A matches up with the graph that they have. Okay, so looking at the two, so my answer is A. All right, which function is represented best by this graph? Okay. So first of all, again, it's pointing down. So I know I need a negative in front, so I can mark out A and C. So I need to figure out which one of these will match up. So let's put those in. Y equals, I'm going to clear both of these out. So my first one that I'm going to try is B, negative 2x squared minus x plus 3. And I'm going to graph that. Well, let's see. It looks like my y-intercept is 3. It crosses here at 1 and about 1 and negative 1.5. I don't know. So let's look at our picture. It crosses at 1. My y-intercept is 3. So it looks like B matches up. Just to make sure, let's go ahead and graph D. I'm going to graph them both in the same viewing window so I can look at them at the same time. So D is negative 2x squared minus 3x plus 1. Here's graph D. So graph D does not cross where it's supposed to. So I know now for sure that my answer is B. Okay? Which statement best describes these two functions? They have no common points, they have the same x-intercepts, the maximum of f is the same as the minimum of g, the maximum of g is the same as the minimum of f. So let's graph these and see what it looks like. So y equals, I'm going to clear these two out. So my first one, f of x is 3x squared minus x plus 6. There's my first one. So let's go ahead and graph that and see what that graph looks like. Okay, so here's a problem. Why is my graph not showing up? Okay, first let's check my y equals 3x, whoops, that should be x squared, delete, x squared minus x plus 6. So let's see if it shows up now. Okay, I see there's something going on up here. Do you remember we changed our window? So let's change it back to our standard viewing window. The shortcut to do that would be to hit zoom 6. Okay, so here's that f of x. Now let's go ahead and graph the second one, g of x. I'm going to go ahead and put that in my y2. So I have negative 3x squared plus 3x plus 5. Graph. Okay, so look at what happens. Here's my first graph. Here's my second graph. It looks like they share a point right here. Okay, so let's look at our choices here. Choice A, they have no common points. Well, that's not true. They do have common points. Okay, my common point was right there. They have the same x-intercept. Well, that's not true because this graph right here never crosses the x-axis. The maximum of f of x. So let's look at f of x. F of x was this graph right here. Does this graph, this parabola, have a maximum? Well, it doesn't have a maximum because it opens up. It has a minimum. So I know it can't be C. But D says the maximum of g of x, so here's g of x, the maximum of g of x is the same as the minimum of f of x. And that's true. So my answer is D. Okay, let's do the next one. The next one's very similar. Which statement best describes these two functions? Okay, so let's graph them and see what they look like. So in my y1, I'm going to put x squared minus x plus 4. Let's graph that and just see what it looks like. There it is, x squared minus x plus 4. Okay, in my y2, let's graph negative 3x squared plus 3x plus 7. Let's graph that. Okay, so this time they intersect. So let's look at our choices. Which statement best describes these two functions? So remember, the first one that goes up is f of x. This one that goes down is g of x. So it says the maximum of f of x. So do I have a maximum on f of x? No, because it opens up, I just have a minimum. So that's out. The minimum of f of x. So the minimum of f of x, which is be right here, is less than the maximum of g of x. So if this is the minimum, if this point right here is the minimum, and this right there is the maximum, is the minimum of f of x less than the maximum of g of x? Yes, it's less than because it's below it. So my answer is B. Okay, one more. The length of a rectangular swimming pool is 20 feet greater than the width. The surface area of the pool is 1,500 square feet. What are the length and width of the pool? So we should know the area of a rectangular swimming pool is length times width. Okay. Now it told us the area. The area is 1,500. And then what did it say? It said the length. So the length of a rectangular swimming pool is, so equals, 20 feet greater than the width. So my width plus 20. Okay. So let's look. I know my length. My length is W plus 20. I know my width. It's just W. So now we're going to have to solve this. So I'm going to distribute that W. W times W is W squared plus 20W. Now I'm going to set this equal to 0 by subtracting 1,500. Okay, and now I'm going to have to solve this. All right, when I solve this, there are lots of ways we can solve quadratic equations. We can solve by factoring, solve by graphing, solve by the quadratic formula. This is pretty easily solved by graphing. Even though I have big numbers, think of the numbers as if they were, I don't know, 15 and 2. If these were just 15 and 2, I want factors of 15, that when I subtract them, I get 2. Well, 5 and 3 would work. But instead of just 5 and 3, I'm going to use 50 and 30. Because 50 times 30, that'll give me my 1,500. When I subtract them, I get my positive 20. So look, when I set each factor equal to 0, I get W, or my width, is negative 50, or W, which is my width, is 30. Well, I know I can't have a negative width, so I know this won't work. So I know my width is 30, and my length is 30 plus 20. So my length is 50. So it has to be B. Okay, we're going to stop right there, and then we'll work the rest in class on Monday.